To implement a robust over-the-air update for your IoT devices, not only do you need a platform to securely manage your update deployments at scale, but you also need a connectivity solution. Wouldn't it be great to have both integrated seamlessly? The good news is such integration does exist. Eystein, co-founder of Northern.tech, the company behind Mender, and Fabian, global product strategy lead at Once, join me on the IoT Show to discuss a recently announced integration of their two solutions. As you'll see in their demo, this integration takes care of critical aspects of modern IoT solutions, such as security or over-the-air at scale across geographies. That's a great episode with Savvy IoT professionals. Hi everyone, this is the IoT Show. I'm Olivier, your host. Today we have not one, but two guests to discuss over-the-air updates on embedded device. And we have Eystein from Mender, and we have Fabian from Once. And so, hey Eystein. So we'll make some short introductions. We'll talk about Mender, we'll talk about Once, we'll talk about the integration between these two solutions and how they help companies who are doing embedded, who are doing IoT, do it properly, do it right, especially when it comes to updating their software on the embedded devices remotely. So let's start with you, Eystein. Who are you and what is Mender?
Hi, everybody. I'm Eystein Stenberg. I'm the CTO of Northern.tech, the company behind Mender. And Mender is an over-the-air software update solution for IoT devices. And over time, devices need to be updated due to new bug, security, and functionality requirements to keep them in a healthy state, basically. So whenever you have an IoT device, you connect it, it needs to get software updates over time. There's also security regulations that require this, in particular one in Europe called the Cyber Resilience Act that's coming up this year. And what's really interesting about over-the-air updates is that you have to do it a bit differently than what you have in a laptop or, let's say, a server because of the environment being a bit different. So maybe we'll get a bit back to that later in the...
Definitely, we'll have a chance for that for sure. And so, Eystein, you came to the IoT Show prior when I was at Microsoft, and it was a Microsoft thing. So, like, you are a not a regular yet, but hopefully you're going to be a regular. So, if people want to learn more about the details about Mender and how it works and so on, they should definitely go check it out. Check that older episode, but also check out the website. So, what about you, Fabian? Tell us a bit about yourself. Tell us a bit about Once.
Hi, nice to meet you, and thanks for having me. So I am Fabian Kochem from Once. I take care of the global product strategy here. If you don't know who Once is, we are basically a global company who does IoT connectivity and software using cellular technology, and our focus lies on developers to make it as easy as possible for them to build and manage connected products. And of course, firmware over-the-air updates are a huge factor of that. In fact, out of our 18,000 customers that we have globally by now, we found that 95% of them require firmware over-the-air updates. The remaining 5% are actually disposable trackers. So they don't require them, but every use case out there that is not them, they do. Hence why we found it so important to team up with Mender and provide a solution for developers that just works.
Yeah, very much appreciate that. And I think people watching the show, they understand the need for updating software because of security reasons, because of feature enhancements reasons, like many reasons, right? But there are big differences. And Eystein, you started talking about differences when it comes to updating embedded devices and embedded software versus servers and PCs and things that I would say IT has been done for decades now and knows how to do really well. Why do we need different solutions? Why do we need a different approach for embedded devices?
Yeah, it's a good question. So once you start doing IoT for a while, you realize the environment has different characteristics. So, for example, connectivity is very different than from a server. Power is different from a server. So your in connectivity, you're usually on a wireless network, so you might lose connectivity. You cannot connect to a device remotely like you can on a server. It's insecure potentially. You don't know, who is looking at the communication. And on the power side, in particular for over-the-air updates and doing software updates, you might lose power at any time. In fact, the demo we're doing today is battery-powered devices. So what happens if you run out of battery when you do an over-the-air update or a software update? So these are the characteristics that makes it quite different. So you can't just do whatever we were doing in a server or laptop world where you have a much more stable environment, let's say. So what's really important for doing software updates in IoT is robustness, making sure that you can deal with this like intermittent connectivity, power, these kind of things, security, obviously, and also being customizable so that you can support a lot of different hardware and types of devices. Like if you're in server laptop, it's like x86 mostly. And so it's very homogeneous in a server environment. But for IoT, it's a very different story. So when you're doing over-the-air updates there, you need to be able to integrate with all the different hardware and the environments you have.
Yep. Nice. And so you mentioned connectivity a couple of times, but you really focus on the embedded device aspect of things. Fabian, maybe on your side, you can share with us how connectivity for embedded changes or varies compared to a server, desktops, laptops, a fleet of devices that are IT types of devices.
Absolutely. I think the main difference between devices and servers is obviously the amount of computation and energy that exists, right? While servers and the cloud, they have unlimited power, unlimited computational power. The IoT devices typically do not have that. So we have to be really concerned about how much data is being transferred into the device. There might not even be enough memory to accept a whole firmware update at once, so you have to chunk it. This is a problem. But also, as Eystein mentioned as well, the device might be on the go. It might be an asset tracker that is crossing borders internationally. So you have to be prepared to deal with aborted firmware downloads, for example, that have to be paused and continued when there's connectivity again. And also, there's always a little bit of risk, depending on how you do it, that a firmware update fails. And what we see from our customers, this is the worst case possible, because this might break their business case, right? So especially if it's critical infrastructure that is connected and it suddenly stops working, this is a huge problem. And many companies, they fear nothing more than sending out service technicians who must manually fix a device. So this is a very good, all of this are very good reasons to automate this as much as possible and also to have it in a secure way implemented.
Yeah, that makes. I like your story about, not the story, but the risk of breaking a device. It reminds me all the time of an anecdote of. It was a long time ago. A company doing distribution of gas for cars, in UK. I will not name it, but it's well known. They had a touchscreen, or they didn't have a touchscreen. Actually, I remember that they didn't have a touchscreen on the pumps, but they pushed an update, and that update required. For some reason, there was a pop-up that came up and required a manual click on to approve or accept something, right? Yeah. And there was a mess up between pushing an update that was not tested properly and not paying attention to the fact that the target was different types of devices. And so they basically braked all the fuel pump in the country overnight. And they had to send someone, or like operators, maintenance people, to the devices to insert a USB keyboard and press OK. and true story, I cannot tell you what the sources are and so on, but this is exactly a use case that, is critical. You do a little software update, it breaks everything. They're remote. They don't have an operator. They don't have someone in front like a PC or a server that, you can say, hey, reboot that thing and things will be fine. So that's definitely a cost, and we're not even talking about the millions of dollars per hour of downtime on factory, chains and things like that. So that's definitely justifying the need for having a proper solution. So if I want to simplify things, once is about connectivity, Mender is about the over-the-air update, the actual software update applied to embedded device with everything that is implied there. Let's look at a demo of that integration between Once and Mender and how it addresses some of these problems that we just mentioned.
Sure. Let me take over and show you what we have brought. So we have brought this very nice device from Nordic Semiconductors. It's called Thingy 91. It's basically a prototyping board for developers. It's very popular also in the open source community. And it has a module in it that supports two different radio access types, narrowband IoT and LTE-M. Both are radio access types that are primarily built for IoT devices or connected products, so very much specialized in here, but it uses similar or even same frequencies that your mobile phone would use as well. So this is a very good board. And what we have done basically is we have used our open source SDK from GitHub. We downloaded it, we compiled it, and flashed it onto the device. Then we have also done a LED color. You can see it here. It lights up blue at this very moment. And when the device will be updated, or after the update, the goal is to have this LED light up green. So everything based on our open source implementation here. And if we go to the customer portal of Once, you see that we have certain plugins in here. And the idea is to extend our software platform, our capabilities built on our connectivity with functionality from a third-party company, in this case, Mender. And as you can see, we have the plugin for firmware over-the-air management installed. The good thing here is that it's really a deep integration of the two platforms. So, for example, what this automatically solves for developers is the entire process of onboarding devices. We take a look at what that exactly means in a bit, but there's no need to install single certificates on the device, for example, no secrets or no passwords, anything like this. Just with our SIM card in it, it's automatically authenticated against the network, but also against Mender, which is, I believe, a huge time saver.
Yeah, so let's be clear. Devices are authenticated, communication is secure, but you don't need to duplicate a device identity, a device credential. You're leveraging the Once credentials and set of identity in order to hook up into Mender as well, right? So because that's one of the nightmares where it's putting together solutions in the IoT world, which is multiplying the number of identities for a single device and how they're represented in your system. It leaves huge gaps because you might forget to remove credentials for a device that is no longer there in one of the systems, and then suddenly that device potentially can connect while it's not supposed to. So really very much appreciate that simplification and let's say using one pane of glass for identity of devices. I think it's huge.
So this is actually the great thing about cellular connectivity, because we sit in the middle, right? We sit next to the embedded device and also next to the cloud, right in between. So using the SIM identity, the ICC ID, actually, this is a very good source of information, and this is why we use it as well. And as you can see, like we have labeled the devices here with a little number. This is actually the suffix of the ICC ID, and we have the device here. And as you can see, it's connected via CoAP, and we are also receiving messages. So this is very good. And with that, I would hand over to Eystein to show the Mender side of things to actually roll out firmware update.
Perfect. I just wanted to start with one thing as well regarding the customizability and like the heterogeneity of the IoT environments, is that we'll do this demo over UDP, over a CoAP protocol. Most Mender customers usually use HTTP, but there's a different protocol in use here. So it's really important to be able to support these different types of network protocols and hardware because it's so heterogeneous. But that said, we have the 3 devices here that Fabian has in his office there, and I'll just deploy an update to one of them. So I created a test group, and you can see like they're all lighting blue now, and hopefully that will correspond with what you can see on Fabian's devices there. But to update a new version, we would need to upload a new artifact. What we call is basically a software bundle. We call it an artifact that contains all the software that you want to deploy. You can see I have a couple here, but this is also where you can upload Delta updates to save bandwidth. So there can be a lot of different types of artifact depending on what you need, what kind of device you have. And now this is a microcontroller, so it's firmware, and it's the whole firmware. I think it's around a couple of 100 kilobytes. 200 kilobytes. But this really depends on what you're trying to update. You can update containers and so on.
So Eystein, we won't unpack all you just said, but there's a lot of things going on in Mender. So I definitely invite people to go check it out, because when it comes to embedded devices updates, we talked about specificities and the fact that you absolutely cannot break it. Well, you cannot break a server in a rack in a factory either, right? But the fact that you can do Delta updates, the fact you can differentiate the app and the firmware, all the things are rather new to embedded development. Like, it has been about flashing a new firmware for a long time because of all these reasons. But now with products and solutions like Mender, you get flexibility to do a more fine tuning and fine updates of your devices with differences between the different locations, different types of devices, but become transparent at an IoT scale when it's about deploying or running a campaign to deploy updates on an entire fleet of devices. A tool like Mender does all of that. So I just wanted to, you are listing a bunch of features, and I'm fairly sure that people will want to learn more. So we'll share the links, after, but I invite people to go check it out because it's really a reach as a solution.
Yeah, and just one addition to that is that when you start to think about, if you're new to over-the-air updates, it seems like a simple thing to do, right? You just copy some software from one place to the other. But once you start looking into it and you get multiple product lines, you want to kind of future-proof this solution, so you don't need to invent a new system for every new environment or product line you have. Then you start to realize all these features that you need and use cases that you need to serve. And that's the journey we've gone through over the last 9 years or so, I think. So
suffice to say, you know what you're doing.
Yeah, I would say so.
One addition to this, maybe, if I may. Also, you might have multiple firmware applications in your device as well, right? You might have your business application, you might have your modem application or firmware module. Like, there's different things that need to be updated, sometimes even all at once, and sometimes they have incompatible versions with another. So there's definitely a lot of complexity that could be there, and therefore you need a system to solve all this.
Yeah.
Okay, so let's create a deployment for the test group that we had in the devices tab. So you can see it here. If you remember, it was on the blue software, so we'll do the green one here. And there's a lot of advanced options you can use in the field here as well. You can schedule it to respect maintenance windows, and you can roll it out gradually, sometimes called a canary release or a phased rollout, to reduce the risk that you brick the entire fleet in case there's a problem with the software, for example. So there's a lot of advanced options. We cannot go through all of them, but for now, I'll simply create the green deployment to the test devices. And as you remember, we had a couple of devices here. If you look in the test group, you can see it's one ending with 9110. So hopefully we'll see that one changing to the green artifact. It's currently on the blue one, but this will take a couple of minutes, I think.
Okay, so we'll speed that one up, and we'll see when it's done.
All right, so as you can see, the device has been updated successfully, and it now has the blue software version. So let's see if that reflects reality on your end, Fabian.
It does. Even though I am on the other side of the world, literally, this is now green. It uses a different firmware file than the other one that has not been updated. So I would say this is a success.
Nice. And yeah, we didn't mention that, but you guys are not in the same office. You're kind of like, you're basically across the world. So it's a real life scenario where you have connectivity established through, 5G, GSM, whatever you have available was once, as you know, the technology allows you to connect these devices remotely, and Mender used to control this deployment remotely. So brilliant, works. So any last word from you guys about, where is that integration going, what to expect next? That integration is deep, as in, you were saying the identity of the device is imagined once, integrates into Mender without having to have a new identity, whatnot. Are there next steps? I know you just announced the integration, but how do you see that going and moving forward?
Yeah, so the goal of the integration, I would say, is to make firmware over-the-air updates over cellular as easy as possible, so that developers, they can focus on their own product release. And now we did this integration with Sapphire over CoAP, and we're looking, obviously, to expand and get feedback to other types of hardware and scenarios. So, but the overall goal here is just to avoid that you need to spend time on all this infrastructure, basically. It should be out of the box. You should get going with your product development and spend your time wisely.
Yeah. Same on the one side of things, right? You mentioned, Fabian, the focus on developers. So developers, as in, here are the bits, here are the APIs, here are the SDKs. We're taking care of the rest, right?
Absolutely. So we really want to make this as streamlined as possible. So everything you can sign up for just like that. It literally takes a couple of seconds in order to get started. Actually, on both sides, this is why Mender and Once we work so well together. We share a very similar philosophy. And the best thing, in my opinion, is that a developer does not even have to talk to any salespeople in order to get started. Just use the online forms and let's go.
Just say the magic word. We don't have to talk to salespeople. Someone will have to at some point, but I think the solution and integration sells itself because it's a necessity. It's something that we need in the world of IoT dearly, and we need it to be done by professionals in a safe way, in a secure way. So that's brilliant. What is the recommendation for someone who wants to learn more? So they can go to Mender.io, they can go to the Once website. Do you have one link for that integration that we'll share in the description down there?
Yes, we do have a link for that. We have all of the documentation public as well. So even if you do not want to sign up, you can take a look what it takes. It's literally the click of a button. Of course, you need a little bit of device integration, but on the cloud side of things, it's really straightforward. So we invite you happily to take a look at what we've done and what we also will release in the future.
Awesome. And Ken, I would just last one question, because I'm tempted to go and try it out for myself. If someone wants to try it out, they have a Raspberry Pi somewhere, whatever, what do they need to go buy or get in order to get started and try that integration?
So with this particular integration, a cellular device would be required, like this one that has just been updated. But there are other devices as well. Even Arduino has something, and you can find cellular developer kits from a couple of bigger brands. So there should be a lot of variety out there that you can choose from.
Okay, awesome. Well, thank you both. I really hope that people will go check out both Mender and Once and that integration, because I do believe it solves a key problem in embedded in IoT solutions in general. Thank you both. Have a nice day, everyone. Thanks for tuning in.